So once again, if I wanted to print an address of character E, what I could do is, first of all, what is the address of character E? Well, I know that there is an address of operator. Ampersand in our programming language in C and C++ is pretty much an unary operator which could be applied to any object that is stored in memory, and we can ask that specific specific object in memory, what's your address? Okay. By the way, this will work now, so pretty much when we do this, this character will be changed to X, right? When we execute this statement, because pointer gets dereferenced, new value is assigned to the first character. But if I wanted to find out the address of character E, what I typically do when I think about it is that I know that all our memory models pretty much index any kind of element, including element in the array, using 0, 1, 2, 3, 4, 5, 6, right? So this will be this new line character. Actually, let me get rid of this new line character. So we're using the same thing in our drawing. So basically, the terminating 0 character has index 5. So therefore, the index of character E will be message, and index is 1, right? Because this character E has index 1, because character H has index 0, and character L will have index 2, and so forth. Right, so this expression right here, address of message 1, will return the address of character E in the array. Because if, let's experiment with this first of all. Right, first of all, if I wanted to print the character itself, I can just say this, right? If I wanted to, I could say this. Let me comment out for a second. So if I wanted to print character E, I can simply use an array element notation and say that I would like to extract the second element, which has index 1 in that array. I'd like to extract the second element of this array, which is character E, right? So this is like right here, right? So this character H has index 1, index 0, I apologize, index 0. Character E has index 1. Character L has index 2, and so forth. Right? So we have those indexed locations in memory, which we can use because a message itself, when you declare an array, if you remember from last week, the name of the array itself remembers the address of the first character. And of course, in a similar manner as we use pointers, when you use message alongside with these indices, you get access to individual elements in this array of characters. Okay, so this should print, let me see. This program right now, as is, let me actually get rid of everything that I don't need, which would be basically this type of program right now. So I have this array of characters named message. I initialize it with some characters, and then I want to print the second character in that array. Build, and then debug, start without debugging, which we did the first time. So I'm printing my character E, of course. Then I'm printing on the same line, press any key to continue. So to remedy that, I can actually add, insert into this output another character, new line. Okay, just like that. If I do this, and again if I build, and if I run this, then I get my character E. So once I get my character E, now I would like to print the address of that character E. Actually, I can keep both. So all I need to do is to say, okay, character E, what is your address? All I need to do is just add ampersand in front of this expression, which refers to character E in memory, and I can say, okay, your character E, what's your address in memory? So it's perfectly fine to combine it like this. And if I run this, I think we will be surprised what's going to happen. So build and then say again, start running, and it prints ELLO. Okay, so this thing right here, it prints ELLO. The problem is not with our thinking about the address of the first character. The problem is actually with, it's not really a problem, but the outcome is really because this stdc out thinks that normally addresses of characters, when they're manipulated by code, usually are designed to pass an address of the first character in the entire sequence of characters. So it does. So what it does is, instead of printing the address of the character, it simply says, "Oh, I am designed." When I'm giving an address of some kind of a string, and we do have a string in memory, it just simply prints everything until it finds zero terminating character. So, so perhaps we need to, if we need to actually make it visible and print the address itself, what we could do is that we could say, first let me show you what I'll do in the standard, if you will, C++ code. I would say static cast square brackets, void, pointer, and then pass this as a parameter to the strange, ugly-looking expression. Let's actually compile this and see what works, and then we can talk about this. I'll just add some spaces to make it not or a little bit perhaps less ugly. Build, and then Control F5 to run this. So here we go. This time, this ugly statement with static cast void message actually printed something that looks like an address in memory, and that is an address of the address of character E. Let me explain to you what just has happened. So I know that this is an address of the character, and here it is, right? I found a way to visualize it. But what I just made happen is that I made cout think that this is not an address of a character, but a pointer to a void object. It's interesting that I told you earlier that when we have, let's just erase some of these things to make space for some other scratch drawing around here. Last week we said that if we have a pointer variable and it contains, say, address of character E, if we have it like this, the pointer, which we declare as character pointer, for example, PTR, and initialize it with an address of the character. For instance, I could just say equals address of message, right, message 1. I could have done it this way. And so this pointer variable right here points to this character. I told you that when I think about pointers, I know that pointers normally are aware of two things. One thing is, of course, the address, which I draw with an arrow. But the second thing, which I usually draw in my mind as a second frame around it, which essentially says it knows the size of an object, like this. It knows, for instance, that the size of character E is 1 byte, right? 1 byte of addressable memory. So when you declare pointer a void, void pointer PTR, you essentially, if I did this instead of char, if I declare this pointer PTR as void pointer, this removes the knowledge about the size. This just essentially gets rid of this second thing. Void pointers can be very useful. This void pointer can be very useful when, for example, you interact with an operating system. Suppose that you have some kind of graphical library and it wants to interact with you. You can say, well, I have this window or button on my screen, and I want you, graphics library, remember the address of that button. So the graphics library may not know exactly the type of my button or the type of my window. And in that case, to make it generic, you can pass a void pointer. Essentially, the pointer with information about the object type removed. It is only representing the address. So you have to cast it, and that's what I did. You have to cast it to a specific object, and the static cast is the operator that does that. This is the safest way to manipulate the types of pointers in C++. But this is in C++. In C, the cast, I kind of showed you the hard way of doing the cast. In C, casting is done this way, simply using the round parentheses and saying, look, this is the address of the character, but I don't want cout to know that this is an address of the character because the silly implementation of it is going to print the entire string. Instead, I want it to print the address. And this is like unconditional C-style cast to a void pointer, which essentially removes the information about the object type that the pointer is pointing to. Okay, so this way, so this is the second version of our program. Let's make sure I save everything, and if I build this and if I run it, it should, oh, actually it failed something. Oh, because my program is still running, I need to dismiss it and go back and build and then run it. And so here we go, right? So this still prints the address and it still works just fine.